Hey there, welcome to another video on math problem solving. This is Bharat Divyang from Zigzag Academy, and today's problem is from DMath, DHI Math. Please check them out for some really interesting problems. Today's problem is about a triangular grid. As you can see, there's a huge grid, and the question is what's the maximum number of triangles that can be traversed starting from a triangle and moving to adjacent triangles via an edge without revisiting any triangle. Okay, so an example has been given here where you say, like, okay, I'm starting from this, I go to another triangle, and from here there's an edge, from here there's an edge, and I keep going this way and finally get to a point where I reach a triangle which doesn't have any other triangle after that, because I can't go here, that's already visited, this is already visited, so those are the only two adjacent triangles, so I'm locked up here. So the starting criteria is anything, you can pick up any of the triangles. The ending criteria is that you go to a triangle where there's no more adjacent triangles that you can move to, and therefore your traversal has come to an end. The question says, what's the maximum number of triangles that can be traversed starting from a triangle? So you need to figure out what is the maximum number. So now I've told you this problem solving method multiple times. The idea is always to say, do not take it at face value. I know there's a huge list here of huge number of triangles, but start with something much simpler. The simplest one I would say is, to me, level one, which is, a triangle at level 0 and triangle at level 1. So you can think of the images here, you can think of the levels here. So I would say this is level 1, and ask yourself how many triangles are there, and the answer is 1, 2, 3, 4. And question now is how many traversals are possible. So you can start from here, which means 1, 2, 3 as shown here, which means this is left out. You could also go 1, 2, 3, which means this would be left out. You could start from the center, you go only to one other thing, which means 2 would be left out. So the maximum here, the traversal always seems to be 3, and the one that is left out is going to be 1. This is your level 1. 4 triangles, 3 traversals, 1 that's left out. Now let's go to level 2. Level 2 because this is level 0, this is level 1, this is level. As you can see, the number of triangles added up is 1, 2, 3, 4, 5. So 5 triangles added up to 4 already, that's there, which means that's an addition that leads to 9 possible triangles. And let's look at the traversal. You start here, it's like 1, 2, 3. If you go here, you're stuck. Therefore, 4, 5, and 6. So it's 1, 2, 3, 4, 5, 6. You either go up or you go here. In either case, it's 7, and therefore 2 are left out. Okay, in level 3, the number of triangles that's added up is 1, 2, 3, 4, 5, 6, 7. 9 plus 7 is 16. And let's look at the traversals now. Starting here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 10, 11, 12, and 13, leaving out 1, 2, 3. So 13 and 3. So as you can see, there's a pattern to this. With each level increase, you're increasing the leftover by 1. So it's 1, 2, 3. And the number of squares seems to be perfect squares. Right? I mean the number of triangles. So it's 2 squared, 3 squared, 4 squared, and it keeps going. So you can actually predict this. For level 4, there should be 25 possible triangles, and there should be a total of 21 that's traversed, leaving 4 empty. Let's test it out. Starting from here, 1, 2, 3, 4, 5, 6, 7. Leave this out. 8, 9, 10, 11, 12, 13. Leave this out. 14, 15, 16, 17. Leave this out. 18, 19, 20, 21, maybe. Right, so 21 with 4 left out. So there'll be 2 left out here and 2 left out here. A total of 4 that you cannot traverse to. So this is 21. Now the question is, in the original triangle, how many levels are there? So this is 0, 1, 2, 3, 4, 5, 6, and 7. So if the level is 2, the number of triangles is 2 plus 1 square. That's how it works. 3 plus 1 square is 14, 4 plus 1 square. And we know that we have a total of 7 levels, so eventually you can come down to that. 7 levels means 7 plus 1, which is 8, 64 squares. And when there's 4 levels, there's 4 left out, and 7 levels, there'll be 7 left out, which means there should be 57 squares would be the maximum, 57 triangles would be the maximum number of triangles that you can actually traverse to. But the key thing is not about what this problem is about or what the answer is, but how you solve it. So there is, of course, this whole brute force method where you can actually try to traverse this, but it leaves you with a bit of doubt because you know that you're going to avoid the ends. So keep going the same way, and you'll realize that, okay, the moment I go here, I want to leave this end. So it keeps alternating. So you leave this end of the triangle, this end of the triangle, then this end of the triangle, 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 this end of the triangle. And you'll realize that, a total of 7 is what you need to let go of. So 57 would be your answer. Okay, so the problem solving method, that when you look at a problem like this, probably in your AMC Olympiad or any other Olympiad problem, don't get bogged down. Don't resort to brute force as the only way to do it. I mean, you can use brute force, you can still find the answer. But I would suggest that trying to break it down and say that, okay, is there a formula for n levels? And the answer is yes. If there's n levels, you would have n level, n plus 1 square would be the number of triangles, n would be the number of leftovers, so n plus 1 whole square minus n, which is n squared, plus 2n minus n is n plus 1. This would be the most generic answer depending on the level. I hope you found this video interesting and insightful. If so, please do like, share, and subscribe. Looking forward to seeing you in the next video.